they had changed the gradation grade 1 that was given in MORTH by limiting the fines content which were passing 425 micron, and they have suggested to use this material for all their national highway roads. And for this kind of material, the permeability that was expected was as less as 23 meters per day, right? So, I think I will skip some of the literatures what I have discussed. So now the overall overview of all this literature is that all the researchers, they say that if you use non-plastic crushed aggregates of sizes above 26.5, definitely it can give a permeability of 300 meters per day, and definitely the drainage system can be effective, and it will help in the better performance of the payments. So in the present investigation, we have carried out 2 phases. In the phase 1, we have conducted laboratory studies by developing a laboratory mold, permeameter mold, and in phase 2, we have slightly increased the scale of the permeameter. So we have gone for a large scale model and conducted the studies. So in the lab studies, again we have used the non-plastic crushed aggregates meeting the various gradations starting from grade 1 to grade 6 of the MORTH specification, and along with this we have also taken the American specification, that is AASHTO 57, just to make a comparison with our gradation and the American specification. So the experimental setup, I think I will directly so this is an experimental setup what we have. This is a horizontal permeameter that we developed of size 0.6 meters length and 0.3 by 0.3 meters. And here we have provided a brass plate. So we have provided 2 brass porous plates on either side. So you can see this is a representation of our horizontal permeameter. We have an inlet here and we have an outlet. The inlet is at the bottom and we have an outlet which is provided at the top. And this is the effective specimen size of 0.3 by 0.3 by 0.3. We have a water channel on either sides to collect the water. And the porous brass plates which are provided on either side, they were lined with a geotextile lining in order to prevent the clogging of the pores by the fines that are passing out along with the water. And we had a overhead tank through which the water was supplied, and so this is the experimental setup what we have. And we selected some materials which are locally available from a nearby quarry in Bangalore and conducted all the basic tests. And we also did the compaction as per the standard specification. So this is our mold which we have developed. So this is the length of 0.6 meters and 0.3, and the depth is 0.3. And there are 2 water channels provided on either side. And this is a porous plate which is provided on either side again. And it is lined with a geotextile lining on the inner side, which of course you will not be able to see. This is a material which is compacted in our mold. And the other important aspect in this study was, generally when we do a vertical permeability in the lab, we maintain a head of unity, that is 1. Now in this horizontal permeability, it is similar to what happens, the drainage what happens in the field. And again, research says that, the literature says that when we conduct a horizontal permeability, the hydraulic gradient should not be more than 5%. So it is, the cross slope is to be maintained between 2.5 to 5%. So this is a hydraulic gradient what we have maintained in our lab also. And to maintain this hydraulic gradient, we have 2 piezometer pipes which are fixed to the inlet and the outlet, and the differential head was maintained by providing some extension pipes on the outlet side, and the hydraulic head, the hydraulic head was maintained by additional attachments that are provided on the outlet side. Yes, sir. So this is our experimental setup. You can see there is a water supply to the inlet, and then there is a discharge that is collected here. So before we start with the permeability test, we ensure that complete saturation takes place. So minimum of 24-hour saturation was allowed, and it depends upon the dense graded mix. So it depends upon the type of mix. Generally dense graded mix will require more saturation time. So we have ensured that there is complete saturation. So once this was done, Similarly, in the large scale field models, we have developed a large scale model. I will just show the photos. So this is a field model what we have developed here. So you can see this is a model of 1.5 meters by 1.5 meters by depth of 1.5 meters. So here again we have repeated the same setup what I explained, what we did in the laboratory, and you can see this is a photograph of the GSP mix that is mixed in a concrete mixer to ensure homogeneity, and it is being laid here and it is compacted, and this is a top view of that large scale field model what we have developed. And here the hydraulic gradient or the hydraulic head was maintained by lifting the inlet side of the permeameter mold by using a hydraulic jack. So you can see in this photo there is a hydraulic jack. So we lifted on one side, that is on the inlet side, to have that hydraulic head difference. So this is a discharge what we are collecting on the other side, and we continue the process until we get a constant discharge. And then coming to the results, all the basic results were matching with the requirements. So this is the horizontal permeability results what we have got. So as I told you here, the open grades, that is grade 3 and grade 4, they were meeting the minimum requirement of 300 meters per day as per ASTO specification. But the dense grades, that is grade 1 and grade 2, grade 5 and grade 6, they were much lesser than the 300 meters requirement. So this even in the field model, if you see, in the field model, apart from the different gradations, we have also tested for the combination of open and dense grades. So usually we provide GSP in 2 layers. So the lower layer is the open grade, and the top layer is the dense grade. So you can see the results what we have got here. In case of the combination of grade 3 and grade 5, and grade 3, grade 6, grade 3, then grade 4 plus grade 5, all these are giving higher permeabilities. It is almost in thousands, few thousands. Whereas the dense grades like grade 1, grade 2, when they were independently tested, they have given very less permeability value. So these are some graphs what we have drawn. So the discussion is that, of course, there is a scale effect between the lab and the field model, which is actually showing some variation in the result. In the field, we are getting very high permeability values, particularly for the open grades compared to the dense grades, compared to the lab results. But what is happening in the lab is, it is a constrained model, that is there is better degree of confinement and better densification of the material. Therefore, it was giving much better, it was giving lesser permeability when compared to the field model. Whereas in the field, though we ensure that the sufficient compaction is being done, but the densification is not happening to the extent what is happening in the field. So that is one of the reason why there is no no continuity of the pore spaces in case of the lab model. So the final conclusion what I would like to make is, in case of the ministry specification, that is grade 3 and grade 4, they are definitely meeting the minimum requirement of 300 meters per day, but the dense grades, the choice of the dense grades can be definitely reduced. Instead of providing 4 dense grades, grade 1, grade 2, grade 5 and grade 6, probably the choice can be brought down to 2, but however we need to ascertain the structural stability of these dense grades before we eliminate any of them. And in the present study, in spite of using non-plastic crushed aggregates, we have not used any gravel or any combination of gravel, but in spite of using non-plastic crushed aggregates, the dense mixes were not meeting the minimum criteria. So when such is the case, we need to think when we are using for rural roads, even today in rural roads, we are using a combination of gravel with aggregates. So how far this will help in drainage, we are not sure. So we need to think, and that is definitely a question mark when it comes to the drainage of the GSP in the rural roads. So the limitation of this study is we have not considered any rainfall intensity, which is actually an important parameter that has to be considered for drainage characteristics. This being the research study, we have subsequently done this, we have considered the rainfall intensity also. So I finally would like to thank the Volvo management for supporting this research and all the Rasta management. So these are some of the references what we have gathered. I thank everybody, and I thank the IRC for giving this opportunity to present my paper. This is definitely an honor because in amidst so many great people and experts here, I have got an opportunity to present my research study. So definitely it is an honor and thank you for that.
Thank you, madam. Now next I invite Dr. S.S. Porwal, Satinder and Nahar on the choice of composite pavement with asphaltic overlay technology. Please, Dr. Porwal, please.
Respected Chairman, Co-Chairman, dignitaries on dais, of the dais, ladies and gentlemen. Now, I would just go into detail how we need the requirement of the composite pavement. In fact, you all know Border Road Organization is working in a very difficult area, extreme climatic conditions, difficult geology. And when I was a task force commander, particularly between 98 to 2001, on Manali Sarchu, we used to have a lot of stretches which surfacing means the pavement did not behave. Some of the stretches were like Rani Nala. The snow clearance used to be more than higher than this hall, 50 to 60 feet. So whatever road we used to construct, it used to go bad in one season. So then we thought, let us find out some proper solution to this problem. So in fact, like engineering colleges and research institute, they do laboratory work for border roads. Our field stretches are laboratory. We select a small stretch. We have authority and power, so we carry out some trial and say some of the trials out of say 10 trial, 3, 4 may fail and 2, 3 may succeed. So Mr. Satyendra, in fact, Dr. Ciara and Satyendra, we had invited CRRI. That time I said composite payment, so the people later asked, what is a composite payment? And it is a situation basically, it all depends where it is to be used. Rigid or a flexible over rigid, it will depend on the situation and the extreme difficult conditions. So let me share my experience. So in that Rani Nala, what to do? So while moving on the Coxer side, we found some good flat stone, thick. So we had gone for a composite pavement. We had put some little bit drainage layer, GSB, then a PLC sort of thing. And then we put all these stone slab. Joints were filled with the concrete. And then we allowed this snow clearance. And I was surprised to see, despite of a heavy snow clearance, dozer track chains, lot of flow of water, that stage was intact. In fact, that gave me a encouragement why not to go for something new. Then we had taken up a case with the CRRI, projected a small study on composite pavement, which Mr. Satyendra is going to cover. He has worked, his colleague Dr. Ciara has worked. And now I am happy after the 15 years, 16 years, whatever we thought with the support of CRRI, other engineers, things are getting into reality. Now what is a composite pavement? It is a basically combination. Now we can take advantage in rigid strength, in flexible, the riding quality, other thing. So the combination basically it is a blending of both the things, and still it is on the trial and improvement stage. Mr. Satyendra and his team and many of the other people, they have carried out a lot of work on this. So ultimately now we have a rigid pavement where tire busting and a lot of other issues are there. If we put a small thin bituminous layer and let us see if it can give the riding quality of a flexible, so we have the advantage of the strength of the rigid and the riding quality. So these are the basic concept. Mr. Satyendra is going to cover paper in detail. Thank you.
Respected Chairman, Co-Chairman, dignitaries at the dais, and honorable delegates. So topic is choice of composite pavement with asphalt overlay. If we see the ASTO definitions or ASTM definition, they consider composite means if we put blacktop only on the rigid. But if we put white on the blacktop, some code say it is a composite, some code says it is a white topping. So by chance, I am discussing both the presentations, one from Ultratech side, one from as a author of one of the paper. What is composite pavement? The basic definition is it consists of relatively thin functional top layer of high quality asphalt. Means the grade of whatever the quality of asphalt we can't use simply a premix carpet or OGPC on the rigid pavement, so that it is not a full structural layer. It will acting only as a wearing course, bonded to the lower layer of concrete material. As per the sharp definition, it is a hot mix asphalt over Portland cement concrete, as per IRC 107 also, or PCC over PCC wet on surface. This is also composite. Like we have dry-lean concrete bonded with PQC, this is also a composite. Whenever two different materials are there, they say this is a composite pavement. So in this presentation, I am covering only the asphalt overlay over rigid or stabilized material. What is the function of asphalt layer? Wherever there is a flexible pavement, there is a more frequent maintenance is required. Only at that place we should go for a, not everywhere we should go for a, where are the section, where shall we go for the composite pavement, like heavy black cotton soil is there. In Uttar Pradesh, I have seen many sites, frequent failure of roads is there. Improves riding quality or friction of the rigid pavement, minimizes tire bursting also to max extent. And sound pollution also, in Japan and USA, most of the national highway, they are overlaying with bituminous, they laid a concrete with less cement. Then on the top they put a bituminous layer. Now, what are the technical advantage of the asphalt over rigid to reduce vertical temperature gradient also? Like if we go for a normal rigid pavement, temperature gradient is more, curling stresses are more. If we put this, it is a heat absorber. So your temperature gradient is reduced. We can reduce the thickness also, decreasing curling also, decreasing warping stresses, reduce wearing effect of the concrete also. Like if there is a dust on the rigid pavement also, there will be more wear and tear. In this case, wear and tear will be less. Now, what are the eco benefit? If we see the environment angle, we use, now there is a recent code IRC-Hyderabad-2016, published after 46 years. Means its old was 1970. This code allows use of recycled material, waste aggregate in lean concrete 100%, in RCC 25%, plain concrete 50%. So we can use that aggregate also. On the top we can put a black top layer, allow for the design of lower PCC layer with lower cement content, environment improvement, less greenhouse gas emission, more carbon credit because less use of cement. These are the sections which are given in the ASTO specification. We can have hot mix asphalt over cement treated base. This is a composite pavement, or hot mix asphalt over plain cement concrete. It can be jointed or CRCP, continuously reinforced concrete pavement, or it can be HMA over lean concrete also. So these are the specification. The first part is covered under IRC 37 also. IRC 37 clearly gives the detail how to design flexible pavement over CTB. This is a pure composite pavement. So we can design as per that. For others, I'll try to, the design, basic design which is given is, in the case of granular material, deflection is 0.5 millimeter. If we go for a bituminous layer of it, the deflection of PCC is only 61% less, means 0.18 millimeter, say 0.2 millimeter. The rigid pavement deflects hardly 0.2 millimeter, means you can say 200 micron. So this is the beauty of the asphalt layer. You can get less deflection, your top layer will be saved. It will have less stresses on the top layer. And the basic difference, which road shall we call rigid, which road shall we call flexible, the basic difference which is given in the international code is, if you apply 10-ton load, if deflection is 1 millimeter or more, it is a flexible pavement. If you apply 10-ton load on a rigid pavement, deflection is 1/5, 200 micron. It is a rigid pavement. So sometimes both composites are there. It is difficult to decide it is a rigid or flexible. Do the load test. If deflection is 1 millimeter, it is a flexible roughly. If less than 0.2 millimeter, it is a rigid. Now the designs are also given in the international code, UK, military, Danish, every country they have given the design also. We have also now prepared under the leadership of Bongirwar sir. He is the convener of the composite pavement committee also. They have also prepared a code on it. What are the economics? Like if we go for a blacktop on the CTB, DBM sometime is fully reduced, sometime 50% is reduced. So if we reducing DBM quantity, it means we are saving the environment also. Composite payment with a continuous CRCP is a very cost effective after design life, not initially. Total transportation cost is in all the cases less. Now, if your existing is a too much hard surface, it can be a rigid also, it can be age-old flexible also. Many times you will find slippage of the bituminous layer. The reason being we are not properly roughening the surface. If you will roughen the surface, your area will be more, your same bone strength will carry more horizontal load. So we should have more rough surface or good quality tack coat like PMB, SBS if we will use for that. Modified emulsion we will use, we will get very good quality bond with that. So this is the corner side if you see, there is a pit, this is Awas Vikas Yojana. Every time there were a pit. Like 300-meter good road, then 200-meter black cotton soil, then 300 meter. So every time there is a failure. So there we tried soil stabilizer, we have used commercial grade, RBI grade 81. It was working well. In 15 stretches we have used in Uttar Pradesh. And right side, if you see the side also, this is black cotton soil. If there is a black cotton soil on any road, we have seen Chandrapur, we have seen Goa, you will find longitudinal crack. The basic nature of black cotton soil, they are vertical slabs. Whenever they expand, they give a longitudinal crack. How we will see, if you see this crack, one here, you will find 90-degree here, not 120-degree. If you will find the transfer crack at 90-degree angle. So why we call it black cotton? Because cotton grow there. If you see the in Chandrapur area, most of the cotton is growing there. Its name become black cotton soil. You will find longitudinal crack, whether it is a rigid pavement or a flexible pavement. If it is a building also, you will find corner crack in the window. It is your bearing capacity is low. You will find this type of crack. This is the photo. If there is a cracking in the bituminous layer, either you have to go for a milling. If budget is not there, go for crack arresting layer. Now there are two type of crack arresting layer. You can go for a prefabricated also. You can go cast in situ also. We are using both in Delhi. We are using prefabricated. Fosro company, they have developed this. They dip APP sheet, geotextile from 80-100 bitumen, make a roll, spread on the deck slab. So we will get a crack arresting layer. Or on Himalayan Expressway, we have used geogrid also. For crack arresting layer, you can use geogrid also to arrest crack. If existing is a cracked surface, on the top you want, like concrete road heavily cracked, you put geotextile for composite pavement or semi-rigid material if it cracks. So use this layer. This we use at Himalayan Expressway. Himalayan Expressway, we have used APP sheet, dip with the bitumen, spread it, over it we put a BC layer. This is at the PWD site in Delhi. This is the complete road at PWD site from Janak Tower to ISBT. On all the blacktop, we are having means on the bridge deck, we are having a flexible layer. This is the photograph, Godhra BOT, contractor was B. Sanaya. At many stretches, wherever there was failure of the road, there was multiple raveling, there they are going for blacktop for the repair work. Similarly, at Sir Chandrapur also, we are going for blacktop for the repair, not for the new construction. So now, we have composite pavement on a large scale on Bangalore-Mysore Expressway. The contractor was Nandi Infrastructure. This was the road from Bangalore to Mysore. We have used at Yamuna Expressway also, sir, we have used composite also. On all the deck slab, we have a blacktop. Now, at many places, any slab just next to the abutment, there is a longitudinal crack. On all the longitudinal crack, it is a full failure. That slab we are putting with a BC layer. If you see Yamuna Expressway, you will find more blacktop now because wherever damage is there, we can't wait for 28 days. If we repair with a PQC full depth replacement, you have to wait for 28 days. If you go for a blacktop as a wearing course, within 3-4 hours when it gets a room temperature, you can open the traffic. So this is the beauty of this. This is Yamuna Expressway. Yamuna Expressway also we have used composite pavement on the bridge deck. This is Chandrapur where we have used hot mix asphalt for repair work. For Godhra also Chandrapur project. On many sites we are using mastic also. This is also a composite pavement. Where old bridges are there, we are going for a mastic. This is the construction which is going on in Delhi for the